We have been talking about domain and range. We did domain and range for discrete relations. And for discrete relations, remember those are just scatter plots or just points. And what we would do is we would just list out all the x values and list out all the y values. But when we do domain and range for continuous is all of the values that are on the line or the curve. There is no way to list out all possible values by making a list of x. Because the x could be, let's say, negative 0.2 is an x value, and then that's like 3. There's no way to list out every possible one because remember there's partials, there's decimals. And so what we're going to do instead is write the interval. So an interval would be, say, the x values are everything in between -2 and +5. So we'll write it as an interval. So I'm going to use a different color for my x values, my domain, and a different color for my y values, which is the range. So I'm going to use blue for domain. So we know domain is our x values. And the x-axis, so we're going to look at this one. The x-axis is the axis that's horizontal. It goes from left to right. So we are going to write the domain as all values of x that are from the left to the right. So whenever we look at this first one, I'm going to start at the origin, and I'm going to count to see how far left the graphed relationship goes. So it's a graphed circle. So it's going to go really, really close to -4 without actually touching. So I'm going to draw a line with how far left it goes. And I'm going to write left, -4. Then I want to look at how far right the graph goes. So I start at the origin and it goes over here. I'm going to draw another line. And I'm going to write right 3. So what I'm doing with domain is I'm looking at how far left, how far right, and I'm creating these lines kind of like boundaries. So what I'm going to use as a way to explain it would be like a fence. So my fence, it goes all the way to -4 to the right, and then it goes to the left 3. This creates boundaries like a fence. So whenever I write my domain, I'm going to write it as whatever the value of the fence is to the left, which is -4. And then the value for the right side of the fence is 3. So I'm going to put a comma between them. And then we need to put either a bracket or parentheses around it, depending on if it actually touches that fence or that boundary. So whenever I look at this, it gets really, really close to -4, but doesn't actually touch it. So this is similar to what we were doing with solving inequalities. If it gets really, really close, we would use a parenthesis. But if it actually touches it, we use a bracket. So we can have a mixed match of parentheses and brackets if we need to. The 3, the relationship, that circle, actually touches 3. So we're going to draw a bracket. So the domain is every x value that is between -4 all the way including 3. So the bracket is if you can touch it or if the fence touches it. Okay, so that's for your domain. You're looking at how far left and how far right. You're creating the fence on the left side and a fence on the right side. Okay, range. Let's get a different color. Range is how far, I'm going to put a Y there. Range is how far down it goes to how far up it goes. So I'm going to put a little arrow here and write down, comma, up. So let's look and see how far down does this relationship go? Does the circle go? And we're going to draw a fence there. And I'm going to write the word down. And it's at, here's the origin, -1, -2, -3. It'll go all the way down to -3 right here. So the fence on the down part is here. The fence on the up part, how far up it goes. So the top part of the fence would be 1, 2, 3.
It's touching, right?
It is touching, yes. So we're going to write it in the order of down, up. So down is -3. Up is +3. And that circle touches the fence on the down part and on the up part. So it'll be brackets. I'm going to use a different color for function, just a pencil or pen.
So why would it brackets this time?
Because it actually touches the fence. So that represents it includes. X can also be -3 because it touches -3. The parenthesis represents if it doesn't actually include the -4. See how it gets closest to -4, but without actually touching. So our function, remember to be a function, we do the vertical line test. So you would see if I put a pencil over the top of my function in a straight vertical line, if it touches twice, then it is not a function. So this one is not a function. And because it fails the vertical line test.
Can we abbreviate the vertical line?
Yeah, VLT. Yeah, that's fine. Okay, let's go to number 2. So I'm going back to my color that I used for domain, which I'm using blue. It's the left and right. I'm going to use a ruler to kind of demonstrate how to do your domain and range. So remember how we were making the fence from left to right for domain? See how this goes right here? But there's an arrow here. That arrow means it goes on and on forever. I can't put a fence there. So for my left side, it's going on and on forever
It's infinity.
to -infinity.
Oh, negative.
Mm-hmm. Because it's going to continue to go left forever. Okay, the right, what if I tried to put a fence here?
It's infinity.
Yeah, it's also infinity. So right is infinity. So then my domain is -infinity, +infinity. And we use bracket if it actually touches that number. But can you ever touch infinity? No. So it's going to have parentheses around it.
This is how I see you actually. You can touch infinity.
No. Okay, the range is how far down and how far up. So I'm changing my color because I'm doing range now. I use kind of like a purpley color. Pinkish purple. So I need to see how far down it goes. Can I put a fence on the down part? Because it has an arrow there. So that means it's going to go down to negative infinity.
Wait, it doesn't have an arrow.
Yeah, it does. Because can I make a fence?
No.
See how I'm trying to make a fence here? And it touches here?
Okay.
Yeah, that arrow. Because it goes on and on forever, down to negative infinity. So up, can I make a fence? Nope. I'm going to write just up. It's going to go to infinity. So it goes left and right forever, and then up and down forever. So our domain and our range are both negative infinity, positive infinity. And it doesn't have to be like that, but linear functions like this that have arrows on the end are negative infinity, positive infinity. Another way that you'll see your domain and range, if they are negative infinity, positive infinity, that means any number that is real, which we haven't learned not real numbers. Those are called imaginary. But this just means all real numbers. So we can write it with the R with the extra line. That means all real numbers. They're called imaginary numbers, and you'll learn about it in Algebra 2.
What about counterfeit numbers?
Okay, so we have all real numbers anytime it's negative infinity, positive infinity. Okay, the next question, is it a function? If I were to do my vertical lines, yep, because I can just go right through and I'm only touching it once with every single vertical line that this pencil makes. So yes, it passes the vertical line test. So if you want to abbreviate that, you can. Let's go to number 3. I'm going to go back to my color that I'm using for domain. Okay, let's look at left and right. So I see how far left it'll go. This arrow means it's going to continue to go on and on. So I cannot put a fence on my left side of the graph. So left, it's going to go to negative infinity. Right, I can't put a fence on the right side either, because there's an arrow there. So it's going to go to positive infinity. So my domain is negative infinity to positive infinity. And we put parentheses because you can't actually touch infinity. Okay, go back to my range color. Okay, so whenever we do our range, we're seeing how far down it goes and how far up it goes. Okay, so I'm going to make a line on the bottom, because that's how far down it goes. There's no arrow there, so I can actually build a fence. It's like a ball that hits the fence or hits the wall and bounces back. So down. It'll go down. What's the lowest that it goes? What is this on?
-2.
-2. Good. So that's the first number I write, how far down it goes. And then how far up does it go?
Infinity.
Yep. Because I cannot put a fence there because it has an arrow. So it's going to go up to infinity.
Would it be negative or positive?
It'd be positive because it's going up. Because it's going in the positive direction. So positive directions would be up and right. Negative directions are anytime you go left or down. So parentheses goes on infinity, but since it actually touches where x equals 2, we can put that as a bracket. Or y equals -2. I said the wrong thing. Okay, is this a function?
Yes.
Why?
That's a vertical line test.
Yep. All right. So what you're going to do at your tables is work with your table to do these 6 problems inside. So I'm going to pause the video and let y'all work on that. So hopefully you've had time to complete it. So let's go over what these answers are. So domain is left and right. I cannot put a fence on the left. So it goes to negative infinity. And then right, I can't put a fence there either because it goes to positive infinity. So my domain is negative infinity, positive infinity. My range is how far down. It looks like I can put a fence on the down part, which is at -2. But the up part, I cannot put a fence because there's arrows, so it goes to infinity. Okay. Is it a function? Yes, passes vertical line test. Number 5, domain is how far left it goes. I cannot put a fence here because it's going on and on to infinity. So left is negative infinity. Same thing for the right side. I cannot put a fence there. So right is positive infinity. Then my range, it will go down to here. This is similar to that other one. It doesn't really look like it's touching. That's at -2. The top, it looks like it actually does touch. Whenever you have an assignment, it'll be obvious whether it touches or not. It won't be iffy like this one is. So what I decided to do was they both touch, so -2 to +2. If you did yours differently because you felt like they didn't touch, that's okay. Function, this is a yes. It does pass our vertical line test. Number 6, left and right. I can make a fence on the left side and a fence on the right side to contain it. Those are your boundaries. So my left side is 1, 2, 3, -3. And my right side is 1, 2, 3. And they actually do touch. So -3 to +3. And then my range is how far down it goes. So it goes down to, what is that? -4. And then how far up does it go?
4.
Okay. And it actually is touching those. So -4 to +4. And then is it a function?
I know.
Oh, no.
It
Yeah.
doesn't pass the vertical line.
Yeah, it fails that vertical line test. because it would touch here and here at the same time. Let's look at number 7, left to right. So I'm going to go left over here, and that is at -2. We can put a fence, but the right side, it's continuing on and on forever. So anytime it goes right, it's going to go to infinity. Bracket goes around -2 because it actually does touch it. And then our down and up, I cannot put a fence on the bottom part because it's continuing on and on. So down to -infinity. And then up, it's continuing on and on, going to infinity. So up is infinity. Is it a function?
Nope.
No, if I do my vertical lines. Okay, the next one is our domain. So how far left does it go? Goes to 2, and it stays there. It doesn't go any further left or right. So it is only 2. If you were to look at this like a table of values, the point here that I just did was 2, 0. Let's say I do this point, that's 2, 4. Or this point, 2, -2. The only values of x are 2. That is the only value. So let's just put a bracket around it. You only need to list it once. You could also have put just x equals 2 as our domain. Go ahead and put that on there as well. Our range, how far up, how far down. So down, it goes down to -infinity. It goes up to +infinity. It is a vertical line in itself, so it's not a function. Okay, the last one is a horizontal line this time. So how far left? And how far right? And then our range is how far up and down. It goes down to -3. And it doesn't move. It just stays there. Kind of like the other one. So this would be 0, -3. This point would be 4, -3. This point would be -1, -3. So see how the y values are only -3? So the only value for y is -3. We could also put y equals -3. Is this a function? If I do my vertical lines, yes, it's only going to pass through once, so it passes the vertical line test. You're going to glue this in your journal, and tomorrow we will do the assignment, which is a card sort.